Well, hopefully not the whole class. We're making it to get, so if you're at home watching this video, it's because you needed more help with the homework. But my goal is to not go through every single problem on homework. So, I know we did some of these in class. We're still going to go through every one. You should have your flippy book out so that you can be referring to the steps. If you're not in my class, you don't have a flippy book, you can always make a flippy book. You can always take notes. Right now, that house over there is actually open to period 3. That's their solving by substitution. So the first thing we need to do in solving by substitution is have one equation that has the variable by itself. And just kind of previewing the homework. Our first problem has one equation where the variable is by itself. Problem 2 has one equation where the variable is by itself. Problem 3, problem 4, problem 5, problem 6. Okay? 1 through 6 all have where one variable is by itself. Then we'll talk about 7, 8, and 9. But 7, 8, and 9, if you had them on a test, you wouldn't use substitution to solve them. You can, but it's probably not what you would do. Can you turn the music down, please? Okay, thank you. So, the first step is to have one equation where the variable is by itself. The next step is to substitute the expression. So this is the expression for the variable. So our first equation, y equals 4x, we're going to take that expression, 4x, we're going to take out the y in x plus y equals 5. And we're going to substitute in, meaning in place of the y, we're going to put 4x. So I'm writing over in blue, that's where my substitution is. Question? Okay. So now I can take x plus what I've substituted, which is 4x, and I get 5x. So 5x equals 5. So that allows me to get to my third step, which is solve for a variable. I have solved for x, and x equals 1. Now, yes?
There's a Chromebook right on the floor out here. Is that yours? Is it
probably. We're recording the video. But that's okay. Oh, that's okay. Oh, now you're part of the video. See? Okay, so we solved. We got x equals 1. So now our second part of our substitution, we're going to take that 1 and substitute it back into the original equation. So the original equation was y equals 4x. Now we have y equals 4 times 1. 1 because that's what we got. And we solve y equals 4. So it looks like we have a solution of our x value equals 1 and our y value equals 4. So a solution is an ordered pair. Remember, if we were graphing the lines, if we graph the lines, they would intersect. Didn't you just ask me to take the hood off? It's okay? Forgot. Now, when I always say it looks like our solution is 1/4, because we can still check it. To check it, we're going to take the original second equation. The equation was, ooh, that's a giant highlighter, was x plus y equals 5. The check is here. But we're substituting in 1 for x, 4 for y, and does 1 plus 4 equal 5? So the solution checks. Okay? Lights going on back there? Made sense? We're going to do a few more. So now we're going to do problem 2. Again, our steps say one equation has to have the variable isolated. which means by itself. Y equals 2x. That's an equation that has the variable on one on side. Yes. Let me finish this problem and then I'll let you go. Is that okay? Or is it an emergency? Oh, I did this one with you, then go. Okay, perfect. Sorry for all of that discussion. Okay. So, here we saw, okay, so we're solving for y equals 2x. So, in the second equation, x plus 3y equals negative 14. I'm going to take out that y. And in the place of the y, I'm writing 2x. So it was x plus 3 times y. So instead of y, I have 2x. Because I was told that 2x equals y. That's my substitution. So 3 times 2x is 6x. X plus 6x is 7x equals 14. So I divide by both sides the 7 and I get x equals 2. So now I'm ready for my second part of substitution. I take the original first equation, y equals 2x. And for the x, I substitute in negative 2. Where did I get the negative 2 from? From what I just solved, right? So I solved for one variable. I plugged it back in. What is 2 times negative 2? It's 2 times negative 2. Negative 4. So now I solved for x. That was negative 2. I solved for y. I got negative 4. So it looks like my solution is negative 2, negative 4. It's a coordinate where if I graphed both of these lines, they would meet. They would cross. They would intersect. So now I know the check's here. I'm going to take that original second equation of x plus 3y equals negative 14. It was that equation. For x, I'm plugging in negative 2. 3 times y, I'm plugging in negative 4. So I get negative 2 plus negative 12, and that's negative 14. Negative 14 is equal to negative 14. It checks. That's my solution. Again, it is the ordered pair. It is the x and y values that work in both equations. If I think back to in my class, we did the first day, we did an example where I was having a party and I had $50 for chips and soda. And we talked about all the different combinations of chips and soda I could buy. It was all different combinations, correct? And then I went to the store and they only had 6 bags of chips left in stock. So then I only had one possible solution. Once I had, you can only buy the 6 bags of chips, that was a characteristic. That was a constraint. Okay? Problem 3. I have a variable isolated by itself. That was the first step. The second step was to substitute the expression in for the equation. Okay? So instead of 2x plus y, I'm taking out the y and I'm putting in the 3x. Third step, solve for that variable. Okay? So 2x plus 3x equals 5x equals 15, x equals 3. Notice on this problem, we solve for x first. Problems 1 and 2, do we solve for x first or we solve for y first? All of those we solve for x first. The next one, we're going to solve for y first. Doesn't matter which one you solve for first. Yes. Right? So back here, I got x equals 3. Now, I'm going to take the 3 for x and substitute it back in to the first equation. So y equals 3 times x, and we said that x is equal to 3. So it looks like y equals 9. Why do I say looks like? Until we check it, we don't know for sure. Okay? That's the nice thing about this. It's extra work, but I know I get the correct answer. If I check my work and it doesn't work, I know I can go back to it. Okay? So for my check, I use the second equation. 2x plus y equals 15. For x, I plug in 3. So 2 times x, 2 times 3. For y, I'm plugging in 9. 2 times 3 is 6. 9. 6 plus 9 is 15. 15 equals 15. So check. Number 4. This is where we're going to switch. They've been telling me y equals something. Now they're telling me x equals something. Doesn't matter which one we do first. It's the same steps. One equation, the variable is isolated. I take the second equation. 3x plus 2y equals 20. I take out the x, and I substitute in negative 4y. Why? Because that's what they said x is equal to. So I'm just taking out one thing, putting in something else that has an equal value. 3 times negative 4 is negative 12. Y. Bring down the 2y equals 20. So negative 12y plus 2y is negative 10. Negative 12 plus 2 is negative 10. Negative 10y equals 20. I divide both sides by negative 10. It's really messy. And y equals negative 2. So it looks to me like my y value is negative 2. Again, when I do the problems, as soon as I solve for one, I make a set of parentheses like that. Although it'd be better if I did it in pen. And I plug in the y. So I kind of have it over to the side so I know what the heck I've done. So now I take the negative 2, what I just solved for, and I plug it in to the first equation. I always do that format. I always plug into the first and check with the second. Can I plug it into the second and check with the first? Absolutely. There's a lot of steps here though. And I find that the more routine I can make it, the less likely I am to make mistakes. Is something funny in the hall? Oh, okay. Pretty funny. We're not supposed to say names on the video. Okay. So, I'm going to take the first equation. X equals negative 4y. And for the y, I'm going to plug in negative 2. Because that's what I just solved for. So x equals negative 4 times negative 2. Negative 4 times negative 2 is 8. So it looks like my solution is 8, comma, negative 2. I'm then going to check it. I think I kind of made a mess here. 3 times x plus 2 times y equals 20. 3 times x, and I have that 8 is equal to x, plus 2 times y, and I have y is equal to negative 2 equals 20. 3 times 8 is 24. 2 times negative 2 is negative 4. 20 plus negative 4 is 20. 20 is equal to 20. It checks. I'm rock and rolling. It's making sense. I'm getting somewhere. Okay, right? Guess what? We're going to keep going. I know it's annoying. It's like, wait, I think I got it. The more repetition you have, the better. Yes.
On the back over there, let's go to the 9. Well, I actually got it.
Okay. So yeah, you always have to go to 9 on the back. And when we get to 7, 8, and 9, I'm not going to do them all in the video, but I'm going to talk about how to at least turn one of them to a variable by itself. Because reality is, it's not how you would solve it later on in the chapter. So I kind of wanted kids to be exposed to it, but I didn't want them to stress. If you can do problems 1 through 6, you have what you need to know for it. So, problem 5, again, we have a variable. Right now it's a little different. Before we've had like x equals, I've had like just, it's a different type of problem. If you look here, this variable is equal to something times the other. This is multiplication. This is multiplication. This is multiplication. Here it's a little different. Y is equal to x plus 1. So we take out this entire y and we put in x minus 1. That's in parentheses. Now, we can't subtract 1 from x, can we? They're not like terms. But remember, you can multiply in any order. So if we take those parentheses away, I just said multiply in any order, that's not what I meant. I mean, multiply in any order. I meant add. So you're combining like terms here. What's x plus x? What's x plus x? 2x. Minus 1 equals 3. I add 1 to both sides. I get 2x equals 4. And if 2x equals 4, x equals 2. So now, same thing I did before, I plug it back in. If y equals x minus 1, and x is equal to 2, I substituted this 2 back in for x, and 2 minus 1 is 1. Now I'm going to check my work. Okay? 2 for x, 1 for y, so 2 plus 1 equals 3. Does 2 plus 1 equal 3? Yes. Yes. Okay. So you have to show all your work. You haven't been good. And while we're going through it, you're not writing anything down. So guess what you're going to have to do when you finish? Watch the video to write all that work down. Okay? Beautiful! Love it. So excited when it works. Because by doing it this way, we have no zeros for homework, right? You should never have a 0 for any of my students for homework. And actually, if you're in support, you should always have the full 5 points, right? Because we're doing it in support. And if you don't have me for support, you have somebody else, well, most of you at this point now have me, and maybe at least going through a few helps out. So, last problem where we have a variable isolated. X equals y minus 7. So this is equal to x. So in the second equation, I'm going to take out the x, and I'm going to substitute in y minus 7. That's my substitution. Start to get why it's called solving by substitution. So if y minus 7, I can't combine anything there, correct? But I can combine the y and the 8y to give me 9y. The negative 7 stays the same. 9y minus 7 equals 2. I add 7 to both sides. So 9y equals 9. And when I divide both sides by 9, I get y equals 1. Oh, I wanted a highlighter. It didn't work. There we go. I don't know if you can even read that. So again, I make my little coordinate points in the parentheses over here so I can keep it straight. I solve for y first. Because sometimes what happens is you solve for 1 and then you forget what I just solved for. So now I plug that in to the first equation. 1 minus 7. 1 minus 7 is negative 6. It looks like my solution is negative 6, 1. So I'm going to plug that back in. So my second equation, x is negative 6 plus 8 times y. Y is 1. Negative 6 plus 8 is 2. Negative 6 plus 8 is, actually is 2, right? Negative 6 plus 8 is 2. It checks. So you, good refresher, we have a quiz coming up, would be, can you do problems 1 through 6? We have a quiz, what day is the quiz? Oh, next, a week, no, it's end of this week, next D-Day, Thursday and Friday this week is the quiz. Okay?
Wait, so what day would I take it since I've done 3?
Thursday. Okay. You're not going to fail. Okay? So, for these, you needed to get a variable by itself. Now, honestly, looking at this, I'm not sure why I isolated for y here, for number 7. It would have been easier. Not sure what I was doing. X minus 5y equals 10. So to get x by itself, I could have just added 5y to both sides, correct? And x would equal 5y plus 10. Okay. Now, this ends up being the same line. I think maybe that's why I didn't slope intercept form. Again, this is not the type of problem I would give you on a test, on your quiz at this point. This is actually a problem that will be best served by solving, by multiplying, dividing, then eliminating. And we don't do that lesson till next Thursday after the quiz. Okay? Same thing for number 8. If you were able to do it and get same line, I would have infinitely many solutions, that's great. If you couldn't, don't worry about it. Number 8, okay, was 4, I think it's 4, 3. Okay? Again, this is the type of problem that would be best served by multiplying or dividing first. Yes?
Would this be right?
Yeah, that is right. That actually. Okay, so when you have to end up solving for it, you get infinitely many solutions. You're just going to solve it for that.
Oh,
Okay? That's okay. That's okay. And number 9 would have been 9 over 4. Again, I'm not going to worry about that because I would do it by solving by multiplying first. The reason though I still put them on the homework and made you kind of look at them and be like, ah, is really more, yeah, that's it. Guys, I'll be honest, was a little bit so, when I go over multiplying and dividing, I'm going to revisit this homework, these homework slides. And I'm going to show you, oh, now I understand why I want to be able to multiply and divide. I will tell you, personally, that I got through Algebra 2 in high school, never understanding what we're going to learn in 6-4, how to do it by multiplying and dividing. And I would solve everything still using substitution, which I can do. I can isolate one of these and get it by itself, but it's a lot of extra steps. Okay? So that's it for the YouTube video.
Bye.
Bye.